Okay, we're going to have a look at experiment 2, which is using your dominant hand and its effects. So we have the same 3 stages as in the first experiment. We need colour here. So we need a reason given for the investigation, and usually this is the thing that's given to you. So using your non-dominant hand to complete tasks is often considered more difficult, but it's also less efficient. So that brings up a number of questions. What do they mean by non-dominant hand, and what that definition is? If anyone's like me, I'm ambidextrous. I write with my left hand, but play cricket with my right, and but then can play golf badly either way, and things like that, and also softball. So I think the easiest thing is to change that and make a definition that your non-dominant hand is the one that you don't write with, because everyone only has one hand that they write with. Otherwise, that may cause some confusion. So the next part is to come up with your causal relationship question. Same structure as before. So that would be, I wonder if using your dominant hand or not causes a difference in the distance a ruler falls before it's caught, based on a sample of Year 13 students. So the key thing is we've got our treatment is using your dominant hand, and we've got our response variable, which is the distance the ruler falls. So one of the reaction tests that you can use is a 30 centimeter ruler, and you can measure the distance that the ruler drops depending on how long their reaction is. So the longer the distance, the higher their reaction. You could replace that with another response variable, which is a computer simulation or something like that. However, with the treatment being a hand exercise, you need something that would test the hand. And the other thing is we've got the Year 13 students, which is our input variable. Okay. Third thing to set up the problem is to look at our prediction, and common sense would say that using your dominant hand will be faster than using your non-dominant hand. Obviously, to go from merit to excellence, you need to research that and find some sort of external information to justify that prediction. So we're now looking at the plan. Okay, so this is exactly the same structure. Just describe how the groups are chosen. So flip a coin, number 1 or 2 and a hat, but as long as they're randomized. The next one is identification of the treatment and response variable, just giving units and details like that. Other sources of variation, exactly the same as before. We need to think of what things will affect the Year 13 students' ability to complete the task. Okay, so for this experiment we have, and we'll have to put a number in there, so we'll say 20 students in the Year 13 class who were assigned to either the treatment or control group by giving them a piece of paper, either 1 or 2 on it. Those in group 1 used their dominant hand, and those in 2 use their non-dominant hand. During the test, another student will drop the ruler, and the distance it drops will be recorded in centimeters. So it's pretty much exactly the same as experiment 1, except we've changed the treatment and also some details about the response variable. Okay, the treatment variable is if the student is using their dominant hand or not, and the response variable is how far the ruler drops. Again, to make that merit or excellence, you need to then give some justification why you chose how far the ruler drops. Just a discussion like I did about how it's related to your hand. So using a computer or something like that may not test it as much. Would be enough for merit. You would need some sort of external research to back that up if you were to get excellence. So some of the things I came up to reduce any variation. Measurement will always be taken at the top of the thumb to ensure that the measurements are consistent. The same ruler will be used to ensure the weight of the ruler doesn't affect the experiment. No countdown would be given, as students may be able to anticipate the drop and affect results. So again, discuss more how that affects the response variable for merit and excellence. So then we go into the experiment and we can carry that out.